Equations, formulae, and calculations. What are our learning objectives today? It's how to write word equations and balanced chemical equations with state symbols. We are going also to calculate the relative formula mass, MR, from the relative atomic masses, AR. When writing equations, there are two types of chemical equations. Either word equations, where you write the names of the compounds. For example, it is water or calcium hydroxide. You write them in words. The other way to write a chemical equation is by writing balanced symbol equations. Instead of water, you say H2O. Instead of calcium hydroxide, you write the symbols or the formula. CaOH between brackets 2.
Let's take an example of a reaction. Calcium carbonate reacts with hydrochloric acid, and the products are carbon dioxide, which comes out, and water. How do you tell that reaction in an equation? On the left, you write the reactants. Calcium carbonate, you write the formula of each. And on the right, you write the products. Calcium chloride, carbon dioxide, and H2O, which is water. Now, calcium carbonate is a carbonate. When it reacts with an acid, a salt is produced. The salt is calcium chloride, CaCl2. And carbon dioxide comes out and water. Now these are the molecules of calcium carbonate and hydrochloric acid. Do you see here there is number 2. The number in front of the formula is called the coefficient. This means that the number of the molecules. So you have 2 molecules of HCl. 2 molecules of HCl. And the subscript is the number after the atom. It means 2 chlorine atoms. So look at this formula, 1 calcium and 2 chlorine atoms joined together as one molecule. So let's count the atoms in calcium carbonate. 1 calcium atom, 1 carbon atom, and 3 oxygen atoms. Let's count the atoms in HCl. You have 2 molecules, each one has 1 hydrogen and 1 chlorine. So we have 2 hydrogen atoms and 2 chlorine atoms. What about calcium chloride? Calcium chloride consists of 1 calcium atom and 2 chlorine atoms. Carbon dioxide, 1 carbon atom and 2 oxygen atoms. And H2O has 2 hydrogen atoms and 1 oxygen atoms. So you have 1 calcium atom, 1 carbon atom in the reactants, in all of them. You have 1 calcium, 1 carbon, 2 hydrogen, 2 chlorine, and 3 oxygen atoms. In the products, you have 1 calcium and 2 hydrogen and 2 chlorine and 3 oxygen atoms, 2 of them in carbon dioxide and 1 in water. So now the number of the atoms that go into the reaction are the same as the number of atoms that come out as products. And this is a balanced equation. A balanced equation means the number of atoms in the reactants is the same as the number of atoms in the product. Another chemical equation is 2Cl gives Cl2. Now 2Cl are 2 separate chlorine atoms. Cl2 means 2 atoms are joined together by a bond as a molecule. Here is a representation of atoms. This is 1 chlorine atom. These are 2 separate chlorine atoms. ذرتين منفصلتين ومفيش بينهم أي بوند، مفيش أي رابطة تربطهم. And here is two chlorine atoms joined together by a bond. They are represented by Cl2. This is Cl2, the molecule. Another balanced equation is H2S2O7. When it reacts with water and an arrow, the product is 2 molecules of sulfuric acid, 2 molecules of H2SO4. Let's count the atoms of the reactants. Now we have here 2 hydrogen and 2 hydrogen. The total is 4 hydrogen atoms. 2 sulfur atoms. What about oxygen? 7 oxygen atoms in this compound and 1 in the water molecule. So the total of oxygen atoms is 8 oxygen atoms. Now, what about the number of atoms in the product, the 2 molecules of H2SO4? This is the 2. It is multiplied times 2 hydrogen atoms, 1 sulfur atom, and 4 oxygen atoms. So now we have 4 hydrogen atoms, 2 sulfur, and 8 oxygen atoms. So the number of atoms in is the same as the number of atoms out or in the products. Therefore, this equation is balanced. But what about if you have brackets in a formula? This is calcium hydroxide. As you see, OH is surrounded with a bracket and you have a subscript of 2. This molecule consists of 1 calcium atom, then you multiply 2 times the number of atoms within the brackets. When you don't see a number, it means 1. So 2, you have 1 oxygen atom and 1 hydrogen atom multiplied times 2. Therefore, you have 2 oxygen atoms and 2 hydrogen atoms. So the number of atoms in calcium hydroxide, CaOH between brackets 2, is 1 calcium atom, 2 oxygen atoms, and 2 hydrogen atoms. Balancing equations. Chemical reactions between elements and compounds change their arrangement into new combination. The number of atoms that you started with in the reactants is the same as the number of atoms in the product, and by this it is a balanced equation. This is a reaction between methane and oxygen, and the products are carbon dioxide and water. ميثين is the natural gas. ميثين هو الغاز الطبيعي موجود في السلندرز وبيستخدم في الطبخ. بيفتحوا الغاز، بيشغلوا البوتاجاز مثلا وبيحترق مع أكسجين موجود في الهواء عشان يديني carbon dioxide and water as products. ثم دي نواتج التفاعل. Now, methane is used in cooking as the gas which burns with oxygen to produce carbon dioxide and water. Now let's look at the balanced equation. This is a molecule of methane, CH4. These are 2 molecules of oxygen, and the reaction changes how the atoms are arranged and builds new combination of atoms, CO2 and 2 molecules of H2O. Now let's count the atoms that go into the reaction on the left side, or what's also called reactants, المواد التي تتفاعل. 1 carbon, 4 hydrogen, and 4 oxygen atoms. What about the products on the right side? What comes out? 1 carbon. How many oxygen? 4. 1, 2, 3, 4. And 4 hydrogen atoms. And therefore, the number of atoms in the reactants is the same as the number of atoms in the product. Now let's balance the equation for the combustion of ethane. Ethane is C2H6. Again, it's a substance which burns by reacting with oxygen to produce carbon dioxide and water. Ethane بيحترق مع الأكسجين علشان يديني CO2 و H2O. We need to balance the equation, means the number of atoms that go in has to be the same as the number of atoms that come out. Start by balancing carbon atoms. 2 carbon atoms in and 1 carbon atom out. So to balance carbon, we are going to multiply times 2. We put the coefficient on the left. بنحط معامل هنا على أو رقم يعني على الشمال، ومش مش بنغير الفورمولا دي، تفضل زي ما هي. So now the equation is C2H6 plus O2 gives me 2 molecules of carbon dioxide and 1 molecule of water, H2O. Now let's try to balance the hydrogen. We have 6 hydrogen in and 2 hydrogen out. So you need to multiply water or H2O by 3. 3H2O. Now we have 6 hydrogen atoms out. The hydrogen is balanced, 6 in and 6 out. 3 times 2 is 6. Now we have to balance the oxygen. O2, 2 atoms in. How many out? 2 times 2 is 4 oxygen. 3 times 1 is 3. 4 plus 3 is 7. So we have 2 oxygen atoms in and 7 oxygen atoms out. This is not balanced. How do you balance it? You multiply and observe that O2 has to be O2. So the only way that O2 will give you 7 atoms out is multiplying by 3.5. 3.5 times 2 is 7, and therefore you get that you have 7 atoms in and 7 atoms of oxygen out. Now we don't like coefficients with fraction, we want them to be whole number. So we are going to multiply every number or every coefficient in the equation times 2. 2 times 1 is 2, 3.5 times 2 is 7, 2 times 2 is 4, and 3 times 2 is 6. So my balanced equation is 2 C2H6 plus 7 O2 gives me 4 molecules of carbon dioxide and 6 molecules of water. If you count, you have 4 carbon in and out. You have 12 hydrogen in and 12 hydrogen out. And the oxygen, 14 atoms in, and here 8 plus 6 is 14 atoms out. State symbols. They show the physical state of the substance. S for solid, L for liquid, G for gas, AQ for aqueous. Aqueous solution means it is dissolved in water. Here is an equation where the state symbols are written. 2Ks, 2H2OL gives 2KOH, AQ, and H2G. This means that potassium, which is in the solid state, potassium is an element, it is a metal. When it reacts with water, which is in the liquid state, it gives an aqueous solution of potassium hydroxide, and hydrogen gas evolves. So these are the state symbols, S or L or AQ or G, written next to each substance. في عندنا رموز بتبين الحالة الفيزيائية لكل مادة. S يعني solid، مادة صلبة زي البوتاسيوم، لأن البوتاسيوم هو معدن وفي حالة صلبة. لما يتفاعل مع المية اللي هي liquid سائلة L، فهيدينا aqueous solution محلول ذايب في المية. فالAQ اللي between brackets هي الستيت سيمبل اللي بيتحط جنب كل مادة عشان يوضح حالتها الفيزيائية. و H2 of course is gas في الحالة الغازية. Now, how much of each substance reacts in a chemical reaction? Iron reacts with sulfur to form iron 2 sulfide. Iron Fe. S is sulfur. الحديد بيتفاعل مع الكبريت and they form iron 2 sulfide. But how much do you put of iron and of sulfur to have a chemical reaction? When we are baking a cake, there must be certain weights added, either in mass in gram or in cups, in order for the cake components to react and make the cake. The same with chemical reaction. You put certain amounts, certain masses in grams or moles to produce a certain product. Now, how do you know what proportions to mix them in? You can't put the same masses because elements have different masses. Iron is much more heavier than sulfur, so a sample of iron with the same mass as sulfur, this will be, it will have different number of atoms. So how much do you mix of the different elements since they have different masses? Now, let's go to the basics. If you remember, the mass of the atom is concentrated in the nucleus, in the protons and the neutrons. Hydrogen atom has only one proton, and therefore we can say its mass is 1. Oxygen atom has 8 protons and 8 neutrons in the nucleus. We can say its mass is the 8 protons and the 8 neutrons, 16. 16 compared to the hydrogen, which is 1. Carbon atom has 6 protons and 6 neutrons, so its mass is 12. 12 in comparison to the hydrogen atom. So the oxygen in comparison to hydrogen will be 16. Carbon in comparison to the mass of carbon in comparison to hydrogen will be 12. The relative atomic mass means the mass of the atom in comparison to hydrogen. And again, it's similar to the number of protons and neutrons. The relative atomic mass of chlorine is 35.5. If the mass is about the number of protons and neutrons, how do you have half? It's because chlorine exists in nature as a mixture of two isotopes, chlorine 35 and chlorine 37. And the mass, which is 35.5, is a weighted average of these two isotopes. في الطبيعة الكلورين عنده 2 من النظائر. النظائر معناها ذرات من نفس العنصر لكن ليهم different masses. Chlorine 35 and chlorine 37. 35.5 is an average between the 35 and the 37, and the average also takes into consideration the weight. يعني قد ايه موجود منهم، نسبتهم في الطبيعة بيحدد الافريج يبقى كام. فالرقم هيطلع 35.5، والا يعني مش مفروض يكون في الاتوميك ماس halves بس لان عندها isotopes. So isotopes are atoms of the same element which have different mass numbers because they have different number of neutrons, and the average between chlorine 35 and chlorine 37 is 35.5 according to weight and how much of them is there in nature. Atoms are so small. The mass of a hydrogen atom is 1.67 times 10 to the power minus 24 of a gram. So this is 0, 0, 0, 0, 0 zeros, 167 of a gram. So the mass in gram will be a number that's not easily calculated or used. So instead, we don't measure the mass of the atom by gram. Instead, we use a relative atomic mass. Now, this is a carbon 12. You can think of it, it can be equal to 12 hydrogen atoms. Each one of them has a relative atomic mass of 1, and therefore the carbon will be 12. So if you can use a scale and compare the mass of an atom to carbon 12, you can say that the chlorine is 35 and a half, meaning it is 35 and a half times the weight of one hydrogen atom. The same with copper, 63.5 means it's 63.5 times one hydrogen atom, and the sodium is 23. The relative atomic mass doesn't have a unit. It's not uh, it's not measured on a scale. It's just on a scale of carbon 12, okay? And it doesn't have a unit because it is a ratio between the atom itself and the hydrogen, or the atom itself and the carbon 12 scale.
The relative formula mass Mr is the sum of the relative atomic masses Ar of all the atoms present in the chemical formula. For example, we want to calculate the relative formula mass for water molecule. The formula of water molecule is H2O. So now we add all the atomic masses of all the elements within the formula and take care of the number. We have 2 atoms of hydrogen, so it is 2 times 1. We have only 1 atom of oxygen in water molecule, so it is 1 times 16, which is 16. We add all the masses together, so 2 plus 16 is 18. Because it is a ratio, it has no units, but the numerical number of the formula mass, which is 18, is the same as the mass of 1 mole of this substance in grams. So the mass of 1 mole of water is 18 grams. Let's take an example. How do you calculate the relative formula mass of a water molecule? You are usually given the relative atomic masses of the elements H1 and oxygen O16. Water molecule formula is H2O, and now we want to calculate MR. You take in consideration the number of the atoms of each element and multiply it times its relative atomic mass. So 2 times 1, because you have 2 atoms. With oxygen, you have only 1 atom, so 16 times 1 is 16. You add all the values together, 2 plus 16 is 18. Or you can calculate all of them together in this way. 2 times 1 for the hydrogen, because you have 2 atoms of hydrogen, and 16 because you have only 1 atom of oxygen, and the answer is 18. Let's take another example. What is the relative formula mass of carbon dioxide molecule? You are given the relative atomic masses, carbon 12 and oxygen 16. The formula of carbon dioxide is CO2. Therefore, it has 1 carbon atom and 2 oxygen atoms. Find the mass of carbon first. It is 1 atom, so it is 1 multiplied times 12, and the answer 12. Oxygen, there are 2 atoms. 2 times 16 is 32. Then you add all the values. 12 plus 32 is 44. I like to calculate them in one step by saying 12. 12 because there is 1 atom only, plus 2 atoms of oxygen, times 16. and you do the multiplication first before you do the addition. Now, what are the rules for finding the relative formula mass? You find the chemical formula CO2 H2O. Then you find the relative atomic masses of each element C12 O16. Then you multiply each element's relative atomic mass by the number of atoms of that element in the formula. So you multiply here 12 times 1, 16 times 2, and then you add all the values together. And this is how you get the relative formula mass.